Okay, so this talk is Supercharging Java EE applications using JCache. I'm Steve Millidge. I'm founder of a company called Payara. I'm also, or also was, a member of the expert group for JSM 107, which is JCache. And we'll basically talk to you a little bit about how JCache will integrate with Java EE. Now, Java EE 8 may have JCache in it, other than there's no activity at the moment to make that happen. But I'm going to show you basically Java EE 7 on Payara, which is a version of Glassfish. So it's predominantly going to be code, so let me know if you can't see it. It's pretty small room to be able to. Okay, so what we're going to talk about. What I'm going to talk about today is essentially pizza delivery. So we all know about getting pizzas delivered. So I'm going to talk about how a example application, maybe not as cool as the Fight Club application, but an example application for pizza delivery. And it's very much a framework. But imagine that you are a mobile developer in a well-known pizza company. And essentially, marketing come up to you and just say, imagine if we could build a mobile application that talks to our back-end legacy store management system, and then everybody could order pizzas on their phones, track them, track their orders, usual sort of stuff really, and that would be fantastic. That would project us into the #1 pizza company in the world. The problem you have is that the architecture that you've been given is that maybe all these, there's a pizza store backend, which is a third-party application, who knows what it's written in, but it lives in every pizza shop. And you've been given a connector API from a third party to use to talk to this legacy application in the backend. And what you're doing is you're creating the server side for this. So you're creating a JaxRS mobile interface, or well, actually JaxRS backend, whether someone will create the mobile interface on the front. And you've been given these pieces, obviously they already exist, like most organizations, it's a legacy system. And it seems to be built with something called wet string protocol. Okay, so that protocol means that this thing is undocumented, it's slow, could be a challenge, because you've been given that you have projected about 50,000 concurrent users on this system. So that's the challenge that you've been given. So the model that you've also been given is a typical sort of bill of materials kind of model. We have a customer, the customer has many addresses, sorry, has an address, has many orders, each order may have many order items, each order item will be a pizza, or other things. And each order has a store, and each store has an address. It's a typical sort of bill of materials model that you've got, and that's what you have to work with as a data model. So, what we're going to do is quickly look at the code for that, just to understand the challenge. So here's our connector interface. Obviously not fully done, it's something I knocked up. But here's the interface that we're programming to. Very typical sort of CRUD interface. We have find a customer by its identifier. We have get an order by its ID. We have get order IDs for a customer, get orders for customers. Usual sort of CRUD interface, all driven by identifiers. And that's the third-party API. Then if we look at that, how it's been implemented, you can find that this is on the client, this is the server-side implementation. You can find fantastically that, for example, get orders for a customer, takes a customer identifier, and then calls a remote find customer ID in a loop for, finds customer by identifier, then in a loop it finds every order for that customer, and then it basically multiple round trips to the back-end system over WebStream to get to build up customer orders. And unfortunately for us, because it's using WebStream to communicate to the stores, we've got a bit of latency in here. Okay, so we've got a 2-second round trip on the find customer by ID, and get order by ID has 2-second round trip as well. So this isn't going to be particularly quick, which is often the challenge that you face when you try to build a new interface to a legacy system. So we're building Java EE, which is what they talk about. So we ignore this back end for now for a while. So what we do is we create a customer's orders resource using JaxRS. Everyone see that? So I can make it bigger. You okay at the back? Okay. So we create the usual JaxRS resource. It's got a path. We inject a CDI bean, which is this thing here. So this is what we created, a CDI application scope bean. So there's one instance of it, and this is what we're going to use as ourselves to develop to create the connector to the back-end service. So we see we create an application scope bean, implements the interface, and then in our constructor we just create our third-party API, and then basically just call through as an adapter from CDI straight through to our back-end service, which is then going to go to talk to this store. Obviously this is not real code. This is contrived to demonstrate what I'm trying to show. Okay, so we have a CDI bean and a JaxRS resource, and that's all we need to do. So what I'm going to do is I'm going to run that service. So I'm going to run it in embedded Payara. So Payara is an open source project which takes Glassfish source code and builds a variant of Glassfish. I'll have a little bit more about it. But Glassfish, if you didn't know, has a full embedded runtime, so you can run the whole of Glassfish within your JVM. So this is what this piece of code is going to do. It's going to create some blanket boot, empty boot properties, bootstrap a Glassfish runtime, set some properties up, one of which will be the port for the HTTP listener, which is 8080. Start the Glassfish there, and then this bit here is how you run. If you ever use Glassfish, it has an ASAdmin command line interface. This is how you would run essentially any one of those ASAdmin commands from a JVM. And what we're running is a Payara specific command, which is going to essentially enable Hazelcast. So Hazelcast is a distributed data grid which has a JSR 107 implementation, and it's shipped with Payara. Now, if you want to know more about Hazelcast, there's actually a talk after lunch by Payara from Hazelcast, who's a friend and ex-colleague. So I'm going to say, if you want to know more about how Hazelcast works, and his talk will be about Spring, so you'll see the same thing from Spring. But essentially what we're doing in this command is enabling Hazelcast. In Payara, it doesn't come enabled out of the box because Payara is supposed to be a drop-in replacement for Glassfish. So as Glassfish doesn't have it, we don't enable it by default. And then what this line here is doing is going to deploy our WAR file that we're going to build. So if we first build this JaxRS WAR file using Maven, so that will build quickly. And then what I'm going to do is run that REST service. So this is booting Glassfish, and then it's booting Hazelcast, which we'll see in a sec. So that's Hazelcast running. That tells me that there's one member in my cluster. So Hazelcast is a clustered cache, and this is basically this JVM. And we can see our WAR file was deployed. So if I hit this thing, which I've already done. So if we hit that API, we can see that it's not the fastest API in the world. Okay? Because it has to make lots of calls back to legacy systems, and it's come back. So it takes quite a while. If we do it again, it'll take just as long. Okay? So essentially now we have a problem as a developer. So we have a real problem that we have to solve. We thought we'd done it a bit in JCache, 5 minutes, done. The problem we have is it's got high latency. Okay, we have multiple API round trips over wet string. The data model is horrible. It's all defined by ID, and I have to iterate to find lots of each individual order. So that's always going to be a problem with multiple round trips to back end. And essentially, simplicity is not going to scale to what we need to do. And you've been told that the pizza connector is given to you by the third party. You can't rewrite it. It's proprietary. You have to pay them lots of money to access the database directly. So we've got a problem. Has anybody experienced a problem like this before? So what are we going to do about this problem? So one thing we can do is use JCache. JCache is the Java temporary caching API. JSON 107. It's been in development for a long time, but it essentially provides a standard API for talking to caching providers, so caches in general. So you've been to a talk, someone from the expert group, and you're aware of JCache, so you think, okay, that's what I'm going to use. So let's look at how you use it. So if we go back to our connector bean, our pizza customer orders resource is using the API get orders for customer based on the customer identifier. So if we find that in our CDI beans, this is our CDI bean. What we're going to use is JCache to essentially talk to the backend once and then cache the results. So what we're going to do is use CDI to do that. So CDI has the concept of interceptors, which you can apply to a method. And essentially the interceptor gets called before your method gets called. And JCache provides some standard ones as part of the API, part of JSON 107. So we're going to use one of those, which is cache result. We add the import for that. And then we now rebuild our WAR file. So that's rebuilt. We stop our embedded Payara. And we start it again. It'll basically bootstrap the whole of Glassfish in its own JVM. Bootstrap Hazelcast as a caching provider, and then deploy our WAR file. So that's deployed. So now, I'll just make that blank so you can see. If I run that again, see the first call is still it has to go all the way to the back end. Still going to be quite slow. So I've got a large sequence. So there's the results back again with all the orders for Sherlock Holmes. He likes smoked mozzarella and mushroom pizza. If I run that again, you'll see that the result comes back straight away. Okay, so if I make it so you can't see, and then run one again, that is the result. Okay. So essentially, with 12 characters, you just sped up the system by 3 or 4 orders of magnitude, which is pretty good productivity as a developer. And even better than that, what I'm going to do is run a second Glassfish Payara embedded version of your REST service. So if I create a new one on port 8081, and I run that one, so this again will bootstrap a JVM, which will bootstrap a full Java EE server within it, and then bootstrap JCache as well. We see that now we have two members in our cluster. So what JCache has done is taken both JVMs and joined them together into a single distributed cache. And the effect of that really is if we go back to 8081 now and run the same order, we find it comes back quick as well. So that's because they're sharing the same data. Okay, so now we have two instances of our microservice, one for TrendyWord, which are both using the same distributed cache to store the data from the back-end system, all for 12 characters. And that cache is resilient as well. So if I drop the first service and then restart it again, oh, that's not good. So, that's because I changed it. So if I restart the second JVM again, sorry, the first JVM, so I've just basically killed the first JVM, brought it back up again. It'll form a cluster, a little delay as the cluster negotiates. You see there's two members again, and it deploys out like that. And if we go back to the first one, even though it's been restarted, you can see it still comes back very fast. So we created essentially, with 12 characters, created a distributed resilient cache, which is pretty good going. So so as a developer, that's it, job's done. He is all round, ready to go home. We was told our managers it would take 2 weeks to sort out caching for this application, but really it took 2 minutes. Now we've got just interested the other 2 weeks that we managed to steal. So, what just happened? So, JCache, as I said, is a standard API for Java caching. It's JSL 107. It provides a normal API so you can program to it, which Yari this afternoon will talk a bit more about. And it provides a CDI binding, which we've shown. It's a standard, so many caching providers support it. So JCache, JCache, Coherent, all support it. And Payara, we built it into it in the latest release, so it's all just embedded there to go. So the basic concepts of JSL 107 are, we have a caching provider, which is a service and defined in the jar. So that's like a product, like JCache. Then that can create many different cache managers. A cache manager is associated with a class loader and a URI, which is just essentially an opaque string, but can basically product mean something. And then that cache manager manages a cache, and each cache is essentially a distributed hash map with an entry, which is a key to value pair. So it's a key value cache. So, what a caching provider does, that essentially is the product, and that retrieves and closes cache managers. The cache manager creates and destroys caches, and a cache contains objects and key value pair. So it's pretty simple stuff, really. So, what was cache result doing? So, cache result is magic, really. So it's a CDI interceptor. It's a standard one that comes as part of the API. Now, Payara has its own implementation built into it, so you don't need to define it in a beans.xml or anything like that. If you take a another application server, say Tommy or something like that, you would have to get a CGI intercept implementation from somewhere and put it in your beans.xml. It's not provided by providers because it's an application server. So what that interceptor does is it obtains a cache manager, creates a cache name, and it takes your method. So if I quickly go back here. So it creates a cache based on this method name. Okay, and the rules to do that is defined in the API, but essentially it concatenates the return value and the name of the method and parameter names into some sort of cache name and munges it. It then looks that cache up in the cache manager, takes your method parameter values and creates a key. So based on that parameter, it will take that and create a cache key. If you have multiple parameters, it'll munge them together into a single object and work out a deep hash code for those different parameter values. And then what it does before it calls your method, that interceptor, it looks in that cache for an object that already been cached against that key. If it's there, it returns the object to the caller without invoking your method at all. Okay. And if it's not in the cache, it invokes your method, takes the return value from the method, and pushes it into the cache with that key. So if you want to do that in the real JSR 107 API yourself, essentially it's a slightly larger version of this code, which basically gets the cache provider, gets the cache manager, creates a cache configuration, creates a cache if one doesn't already exist, creates a key, and puts it in the cache. Okay. Now, there's more CGI annotations than just cache result, obviously. So there are 4 other annotations that you need to use, which we'll show in a sec. One is cache result, which we've seen. Cache result can actually do a bit more than what I've shown you. It can actually cache exceptions if that's what you want to do. I'm not quite sure why you might want to do that, but if your method actually doesn't return a value but actually throws an exception, you can configure it so that is actually cached. So the next time the method's called, it will also throw the same exception again without calling backend or whatever your method is going to do. It can also define the cache. There's lots of other details to that. So cache put, we'll see in the code, that takes a specific method parameter and puts it in the cache, and then calls the code. Cache remove removes an entry, and cache remove all just blows away all entries in that specific cache. So what we're showing in the demonstrations is we're using Payara. So what Payara is, what we've done is we're a consulting company. We've taken Glassfish open source, we've put all the source code on GitHub, and we're developing and moving it forward on GitHub. It's not strictly a fork because we're still collaborating with Oracle to push fixes back into Glassfish. But we provide 24/7 support. And what we're doing is we're taking it forward as well. So we've taken Hazelcast, which is a distributed cache, and embedded it within Payara with both session persistence and provide JSR 107. So we embed Hazelcast, and we provide all the CDI annotations and integration with CDI that we need to do for Java EE. So let's look at those other CDI annotations and how you maybe use them on your REST interface. So this is our bean again. Let's focus on orders. So we have get order by ID, update order, effectively create order, cancel order. Okay, so let's look at how you might do an update. So the problem with the cache, obviously, normally is that if you do an update, it's not going to be reflected in the cache. So we'll use CDI to try and get that to work. So I've got a SOAP UI to make this a little bit easier, and that might be difficult to see. But there's also a we also have an orders REST interface. So take the get on an order. I'm going to scroll around. So if we run that, that takes a few seconds to run. So that took 2 seconds, which is down the bottom here. Right, so down the bottom there. We'll run it again. So get order takes about a couple of seconds to run at the moment. So let's speed that up. So like we did before, let's go to our get order by ID. Let's do that cache result. And what we're going to do is put some of the parameters. These are some of the parameters you can take to the annotation. So cache key generator is if you want to overload the built-in way of generating the key, you can do that. It's quite something you have to be quite careful of, so you need to get hash code in right. But what we want is going to be cache name. So we're going to put all orders into something called the order cache. Okay, so let's save that, and let's rebuild our var. Okay, and we'll start install our embedded server. So now if we run our SOAP UI, first time takes a couple of seconds, second time comes back straight away. Okay, so that's now taking 20 milliseconds. You can see that's true, so if I run order 2, that'll take a couple of seconds. The second time will take a couple of milliseconds. Okay, so we've also got a so we've got an order resource RESTful web service. And we've got get for get order, but we've also put a post on there for update order, which is basically going to update the status, so like whether it's delivered or not. And if I run that in run that with SOAP UI. So that updates the status and it comes back as delivered. Okay. The problem we've got now is if we go back to our get and run the get again, it's actually still as eaten down there. So it's actually not updated our cache, which is a problem that you get in these systems. So what we're going to do is add another annotation, which is the cache put annotation. On our E. On the update. So we need to make sure we're using the same cache. So we use the same cache. And then you have to use another couple of annotations. One is cache key, which tells it that use that parameter as the key, and cache value, which tells it to use that parameter as the value. So what that's another interceptor. So what that interceptor is going to do is take the two parameters and then put an object in the cache. that key and that value. Okay. Okay, you can also set whether that happens before you invoke your method or after you invoke your method. Okay, we'll always invoke your method, but you decide whether it's before or after, in case you want to do something within your method to those objects. You can also specify whether there are exceptions. So cache forward means if you get this exception from the method that you invoke, then still cache it, and no cache forward means if you get that exception from the method you want to invoke, don't cache those objects. So you've got quite a lot of control of when and if you put those things in the cache. Okay. So if I build that again. So if I rebuild my var, so now what I should have done now is synchronize the cache with my updates. And go back to my RESTful service. Start again. Okay, so that's deployed. Boosted everything up. If I go to my Circular UI again on I run the get, so that will basically return the object on for order 2. So again, because I've blown away all JVMs, the cache is not warm, so that brought object 2 back, and again it's been cached, so it's fast now. If I now do my post to do my update, change the status to delivered on order 2. I run that, you can see that it is delivered. Now if I go back to do my get again on order 2, you can see that it's fast and actually the value is now correct. Okay, that's because what cache put has done is it stored the updated object I gave it into the cache under the key. So obviously, if we were going to build this CRUD interface up, I haven't got REST services for all of them, but that one would be again a cache put, because we're creating a new entry. You would want to put it in the same cache, which would be the order cache. And again, similar to that, you'd have cache key for the order ID. Cache value for the actual order. So then what that would do is as soon as you did a put for that customer, it would take that order ID as the key value and that order place an object of the cache value and place them in the cache. Similar for a cancel, which maybe is a delete, you would use cache remove. Again, you want to make sure it works on the same cache, and similarly you would put cache key there.
You have a timer refresh.
An expiration time.
Yeah. If another system is modifying the underlying system.
Okay. You can set an expiration time on the JSR 107. So irrespective of what the product does, because they may do lots of different things. On the JSR 107, you can set an expiration time at a cache level, not at an entry level. There is an event API, so if that system is also going to use the cache, you can receive events, which I was going to show, but the talk's only 45 minutes, so no chance. I've got other ones I can show on slideshare and things. So you could receive an event and evict from the event. But explorations about anything you could do with that. So it hasn't got a refresh in JSL 107. That doesn't say that Hazelcast has it. But JSL 1 doesn't express one so that you evict and retrieve. But there are concepts of cache stores and cache loaders and things to read right from the cache. You could actually write it a little bit yourself. And then if you wanted to delete all, you just do cache control with the cache name, and that will blow away everything. So, a bit quick. So as a summary, actually using JCache is incredibly simple. It is doing a lot of very complicated things under the covers, but from a pure API, from a CDI point of view, it's very, very quick to do. On Payara, the Hazelcast API is built in, so Payara comes with Hazelcast. You can actually inject a Hazelcast instance, it's raw, or then use JCache if you want to use the CDI. And you can use the raw JSL 107 API as well. You can inject a cache manager as well. So we've also shown Payara embedded to create very small RESTful microservices. And what Hazelcast does, it provides that performance, resilience, and scalability. So it provides a distributed cache that allows, that you can, that is dynamic, so all the nodes dynamically find each other, so you can scale it out, scale it in. So the Payara website's there. I say it's an open source project, so all this code is on GitHub. If you want to actually get hacking around on application server development, take a look at that. And again, this code will be up on GitHub as well. So under my name, Millidge. So, any questions? Got 5-6 minutes.
What about memory management? Who is responsible for? Payara or Hazelcast or something like that?
From a cache perspective, you have Hazelcast. So you can set up Hazelcast to use. You've got full access to the Hazelcast configuration. So Hazelcast will provide configurations to do eviction. So you can do cache eviction if things get beyond certain sizes, that sort of stuff.
Where Hazelcast stores the cache? Is memory or
memory? It's distributed though, so it works on duplicates, so it's not fully replicated cache. So when you put something in the cache, it will define one node as primary and another as a secondary, and you can configure how many duplicates you want, but fundamentally that's how it would work. So the more nodes you add, the more actual data you can store within the cache. Because it's not fully replicated. So if you add 10 nodes, the objects will exist on 2, so you've got all that JVM heap room. You can store, and you can create raw Hazelcast nodes that aren't Payara. So if you wanted to just create cache nodes that are just going to store data, then you can create those as well. Stunned time. So let's say there's another talk by Jeremy from Hazelcast, which is going to go a little bit more into the API, I believe. I'm going to look at Spring and how you use Spring to do the same sort of thing. That's just straight after lunch. And a message from sponsors. That's who's sponsoring lunch today. Right. Thanks very much.
No,